Mora. Let's.
Bienvenidos a todos en este nuevo año 2021 y este nuevo seminario presentado por Mondi Orange Board. En este caso será presentado por nuestro director Serhiy Luzan y será traducido por mí, responsable de ventas de España, Portugal y México.
Before we come to our Mondi expert on this page, my name is Serhiy. I will act today as the host and the moderator. So if you do have questions, please feel free to put them in the chat.
Sasha será el moderador y que recibirá cualquier pregunta de los invitados para trasladársela a Serhiy.
So who is with us today? So we have Mora, who is the sales manager for Spain, Portugal, and Mexico. He's an economist with three years experience in financial management of Airbus military, and I think already over 30 years of experience in the sales of paper for the production of corrugated cardboard, mainly for virgin papers such as white and brown kraft, as well as semi-chemical papers.
Un servidor, Luis Mora, responsable de ventas de Mondi en España, de Mondi Container en España, Portugal y México. Soy economista con 3 años de experiencia en la empresa, en el departamento financiero de la empresa Airbus Military, y 30 años de experiencia en la venta de papeles para la producción de papel corrugado, principalmente en los papeles vírgenes como el craftliner blanco, craftliner café o marrón y los semiquímicos o medium.
And our main host, presenter, Serhiy Luzan, currently head of technical sales service. Serhiy has a PhD in physical chemistry from the Umeå University in Sweden. And as I mentioned, he's head of technical sales service at Mondi Container Board, and there he's responsible for complaint handling, mainly quality, providing customers with technical support during the paper converting process, and of course he's involved in a number of product development projects at Mondi.
Serhiy Luzan, nuestro director de servicios técnicos, está graduado y doctorado por la Universidad de Umeå en Suecia. Sus responsabilidades es el director de los servicios técnicos de Mondi Container Board. Es el responsable de las reclamaciones de calidad y de proveer a nuestros clientes con un soporte técnico durante la conversión y los procesos de conversión del papel, y a la vez está inmerso en el desarrollo de nuevos proyectos en el Grupo Mondi.
So, and without further ado, Serhiy, the stage is yours. Hello. I will be in the back, looking at the chat, and will interrupt you if questions arise throughout your presentation.
Okay, thank you very much, Sasha. Good morning or good afternoon, colleagues, depending where you are. Let me guide you through the content of today's presentation. So I will start with giving you the overview of different print processes in the corrugated packaging. Then we speak in particularly about the flexographic printing. We will review the main components of the flexographic printing unit. Then I will guide you through the main properties of paper, which are relevant for printing. Then we speak about main containerboard white grades, and as we are all very excited nowadays about start of our new paper machine in Ružomberok, I also tell you a few words about our new Kraft White products. And then at the end, I will give you an overview of some common print defects which we experience in our, let's say, daily life.
El contenido del seminario de hoy será una visión general de los diferentes tipos de impresión en el sector del cartón corrugado, una introducción a la impresión flexográfica, las principales características del papel para conseguir una impresión excelente, una visión general de los papeles para cartón corrugado, con una especial énfasis en los papeles producidos en nuestra nueva fábrica en Ružomberok, Eslovaquia, con una nueva calidad de papel, Kraft White. Y finalmente los principales defectos o los defectos más comunes a la hora de imprimir.
So let us jump directly into the overview of different print processes in the corrugated packaging. On this page, you see two main print methods which are used nowadays in the corrugated packaging. This is offset printing and flexographic printing. The offset printing is normally used in a combination with litholaminating process, where you first produce open flute corrugated board, and afterwards you laminate the open flute corrugated board with pre-printed sheets in offset process.
Dentro de la visión general de los principales procesos de impresión, los dos principales serían el offset y el flexo. El offset sería utilizar cilindros litográficos donde se aplica humedad por rodillo. Tendríamos unos cilindros de impresión y solamente se imprimiría aquella parte que no tuviese contenido de agua.
And flexo printing is normally used as post-print technology, where we first produce corrugated sheets and afterwards we print already on the produced corrugated sheets. We also have other techniques which has a smaller market share, about which we will speak later, such as gravure printing or screen printing. But among all of them, I would say the most exciting and the most dynamic print technology is digital, in particular high-speed inkjet technology, where you can print either on paper or on the corrugated board. And in contrast to offset and flexo printing, you don't need to produce any print plates. You can print directly onto the substrate, just simply generating the droplets of ink from the ink nozzles onto the paper substrate.
Dentro de la impresión flexo, normalmente es utilizada la preimpresión, donde preimprimimos el papel que se va a utilizar luego para el cartón corrugado, y luego esas hojas preimpresas son utilizadas para, producir el cartón corrugado ya una vez impreso. Como otro tipo de proceso de impresión, y que a pesar de que tiene un porcentaje no muy grande dentro del mercado de los procesos de impresión, tendríamos la impresión digital, que tiene la particularidad de que no hay que preimprimir ninguna plancha, sino que la impresión se hace directamente gota a gota desde el sistema digital al cartón corrugado.
We will speak in more details about each component of the flexo printing on the later slides. And today, actually, we will not speak much about offset and digital technology, but we will focus on flexo, which is, as mentioned earlier, the predominant printing technology in the corrugated packaging.
No vamos a hacer mucha incidencia dentro de lo que es la impresión offset y la impresión digital, y nos vamos a focalizar más en la impresión flexo.
And just as a starter, let me show you a few numbers, few market-related informations. So in this table, you can see the analysis which was done by Noah Prism in 2015, where they analyzed how much of the corrugated packaging is unprinted, how much is printed with a flexo, and how much is printed with the decorative print technologies. And decorative print technologies here is understood the offset, digital, and also gravure and screen printing. As you see, the ratio is about 11 to 12% of corrugated board in Europe is unprinted. About 70% is printed with flexo, and about 18 to 20% is printed with decorative print technologies.
Yeah. Vamos a ver ahora en esta diapositiva el desarrollo de los procesos de impresión, fundamentalmente en Europa, donde podemos comprobar que en la evolución de los diferentes tipos de impresión desde el 2010 hasta el 2020, y donde podemos ver que hay un 11% no se imprime, aproximadamente un 70% se hace una impresión flexográfica, y el resto es otros tipos de preimpresión diferentes a la flexografía.
Another interesting piece of information comes from the annual FEFCO statistics. FEFCO is a European Association of Corrugated Board Producers, where they publish every year the information about also the amount of corrugated board which was unprinted, which was printed with one color, with two colors, with three colors, and with more than three colors. And in this particular case, I look at Germany, which is one of the biggest corrugated markets in Europe. And what we can see here, the numbers of unprinted packaging or the packaging printed with zero colors is a little bit higher than what was shown by Noah Prism, but we don't really know what kind of assumptions were made here. Maybe some simple text printing is actually considered like zero colors printing. But what is interesting is if we look at the dynamics or the change from year 2018 to 2019, we can see that the amount of corrugated packaging which is printed with one or two colors is actually decreasing, and amount of the corrugated packaging which is printed with three or even more colors is increasing. So we have a trend in Europe here for Germany, but it's not only for Germany, it's for all European markets, that the demand for higher quality printing on corrugated packaging is increasing.
Otra tabla interesante con datos que da FEFCO y fundamentalmente sobre el mercado alemán es cuántos colores se utilizan en la impresión del cartón corrugado. Podemos asumir que 0 es aquel tipo de cartón corrugado que no se imprime, pero lo interesante de esta tabla es comprobar que la impresión en 3 o más de 3 colores se incrementa del año 2018 a 2019 con una pequeña disminución en la utilización de 1 o 2 colores, lo que nos lleva a pensar que la tendencia es que la impresión de mayor calidad cada vez sea más importante.
That is a European picture. Let us look at a more global picture. I took some numbers from the study done by Smicer's peer Pyra, the future of printing for food packaging in 2023. And here again, they analyze the amount of corrugated board printed with flexo technology and with other technologies like offset, gravure, screen, inkjet. All these I put under one subcategory, decorative printing technologies. And similarly to what we have seen in Europe, the global picture is also quite similar. So about 80% of all corrugated board packaging in the world is printed with flexo, and about 20% is printed with decorative print technologies. Interesting to see that going forward, we see a slight decrease in the percentage share of flexo technology, and we see and this drop of the share is picked up by the is predicted to be picked up by the offset printing process, and also in particular by the inkjet printing.
En esta diapositiva vemos la situación a nivel global, a nivel mundial, que muestra una parecida tendencia a la que hemos visto en Europa, en donde vemos que la impresión flexo aproximadamente supone prácticamente un 80%, un 70% de la producción de cartón corrugado impreso. El resto estaría en la litografía, en offset, hueco grabado, serigrafía o de inyección de tinta. La disminución que vemos en la proyección que nos da FEFCO de la impresión flexo, que pasaría de aproximadamente un 80% a un 78%, es tomada principalmente por la impresión inkjet.
That was just the starter to show you a little bit of market related information, but now let's move to our topic of today presentation, to flexographic printing. If we look at the flexo printing unit, there are a few main components here. So the first component is we have the ink pen with the ink, and then we have the Analox roll, which is taking the ink from the ink pen. Then the Analox roll is being, the excess of ink is being removed from the Analox roll with a metering doctor blade. And afterwards, the ink is transferred from the Analox roll to the printing cliché. And then from the printing cliché, which is made out of photopolymer or rubber, it is transferred to the substrate. And the substrate is pressed against the printing cliché with so-called impression cylinder.
En esta diapositiva vemos un diagrama de cómo se produce la impresión flexo con una serie de elementos. La primera de ellas sería donde tenemos la tinta, el contenedor de la tinta. Luego el rodillo o el cilindro Anilox, que es el que toma de este depósito de tinta la tinta. Esa tinta es transferida al cilindro donde tenemos la plancha de impresión y donde se va a transmitir al papel para la impresión.
Interesting to mention that there are different ways to meter the ink on the Analox roll. The one which we show here on the picture, it is actually doctor blade system, where you have the pen with the ink, and then you have a doctor blade, which is cleaning the excess of the ink from the Anilox roll. Except of this metering system, you can also have a doctor roll. So when you have the Anilox roll, and then you have a gap with the metering roll, which is cleaning the excess of the ink. Or you may have a chambered system where instead of the ink pen, you have a chamber with the ink, and then you have two doctor blades here, one which is a containment Anilox doctor blade, and another one which is metering Anilox, which is metering doctor blade. And I would say that for higher quality printing, the chambered system is the most commonly used.
En la gráfica de la izquierda vemos los tres diferentes tipos de cómo la tinta es transferida desde el depósito de tinta al rollo Anilox. En el primero de ellos existe un depósito abierto donde el rodillo Anilox toma la tinta y transmite el exceso. En la segunda existen dos rodillos, uno de ellos transmite el exceso de tinta al rodillo Anilox, y en el último, que es el que realmente es el que se utiliza en las nuevas tecnologías, que sería una cámara cerrada con unas cuchillas reguladoras que transmiten la tinta desde esa cámara cerrada, la cámara blade, al rodillo Anilox.
So if we have one printing station, with one printing station, you can only print one color. So if you would like to print a few different colors, then you have to have a few different printing stations. And normally at the Flexoprint printer, we work with the process colors, so-called CMYK printing, where you use 4 main colors to reproduce your image. We use the cyan, magenta, yellow, and black colors.
Este sistema que hemos visto tendría un color solamente, con lo cual, puesto que normalmente se trabaja con los colores CIMK, cian, yellow, amarillo, magenta y gray, realmente en la impresión flexo deberíamos de tener cuatro cuerpos de impresión, cada uno de ellos teniendo cada uno de esos colores que hemos relacionado CIMK, para conseguir con la mezcla de ellos, cualquier tipo de color que fuese necesario.
Obviously, with the process colors, you can reproduce only limited number of colors, and therefore, if you need to print a special color, then sometimes you may decide to go for a so-called spot color, which is a special color.
Algunas veces, como la combinación de estos colores no nos dan todo el rango, tendríamos que ir a un color y tenemos que ir a un color especial. En este caso se llamarían colores spot.
So if we look at different type of the printed boxes which we may see, I would split them in 3 main categories. One type of the boxes is printed with a homogeneous color without any color gradients, and this kind of printing I will call a solid or full tone printing.
Dentro de los tipos de impresión de la impresión flexográfica tendríamos tres tipos de impresión principales. Uno de ellos sería la impresión sólida, con un tono completo sin ningún tipo de gradiente.
The second type of printing is the printing where we would like to have a color, the same color, but with different with a different color gradient. So let's say in this case with a blue, we go with a darker blue, from darker blue area into the lighter blue areas. And
Luego tendríamos en segundo lugar, no sería un tono completo para toda la caja, sino que sería un color con diferentes tonos.
And obviously, we cannot simply apply a different thickness of the ink film at different part of the corrugated board, because you apply the same thickness of the ink, and therefore we need to find a way how to trick our eye, that our eye sees a different strength of the color. And therefore, so-called a halftone printing was introduced, where in a halftone printing, you split the printed area in the dots, and then depending on the concentration of a dot, if the concentration of the dot is high, the printed color appears darker, and if the concentration of the printed dot is lower, then the printed color appears lighter. So that's how we trick our eye that we see a color gradient.
La forma de conseguir el gradiente de colores se consigue con la intensidad o cantidad de tinta en cada punto. Si es una mayor concentración, nuestros ojos verán un color más fuerte, y si esa concentración es menor, nuestros ojos verán un color más light, más ligero.
And the last class of boxes, I would call it a CMYK printing, where you have a combination of halftone printing done with 4 main process colors, which we have discussed on the previous slide.
Y finalmente el tipo de impresión flexo que ya hemos comentado antes, con los 4 colores principales, cian, magenta, amarillo y beige.
So let us continue looking at the printing plates, flexographic printing plates. Flexographic printing plates in the past were made out of rubber, but nowadays they are predominantly made out of photopolymer material. The way to make flexographic plate is that you have to first make a negative. Then using this negative, you have to expose your flexographic plate to ultraviolet light. And then the areas which were exposed to light, they get harder. There is a photopolymerization reaction happening. And these are actually the printing areas of the cliché. And the areas of the cliché which were not exposed to the light, there the material does not solidify, and these areas can be cleaned. So this is why you end up with a structure as shown here, for instance, where you have a non-printed part of the cliché which were not too exposed to the UV light, and you have a printing part of the cliché which having this kind of elevated surface. And these parts were exposed to the UV light in the plate making process.
Las planchas de impresión flexo están hechas con materiales fotopolímeros, están montados con cintas adhesivas de 2 caras, y los elementos que se van a imprimir están en una superficie elevada, como vemos en la gráfica de abajo, donde las partes de no impresión en el cliché estarían señaladas con la flecha roja, y las partes impresas estarían señaladas con la parte azul, que están elevadas en la superficie del cliché.
After production, the clichés are mounted on the printing roll using 2-sided adhesive tape, and the hardness of cliché and the hardness of the adhesive tape is also important for the printing process.
Excuse me, can you repeat, please?
So after production, the clichés can be mounted on the printing cylinder with a 2-sided adhesive tape. So you put a 2-sided adhesive tape, and then on that tape you put a flexographic cliché, and the hardness of cliché and the hardness of the two-sided adhesive tape, they also are important for printing. For example, if we print paper, then the hardness of cliché can be a little bit higher. If we print a corrugated board, then the hardness of cliché can be a little bit lower.
Ya, cómo montamos el cliché en la plancha de impresión depende de qué producto vayamos a imprimir, con qué fuerza ponemos el cliché y las cintas adhesivas de 2 capas que lo ajustan al tambor de impresión o a la placa de impresión.
So the next point which I would like to discuss is flexographic ink. So the flexographic inks consist of following main components. It is actually the pigment or something what gives ink the color. Then you have a solvent, that's the liquid which is used to dissolve the pigments and other components. The pigments are about 5 to 15% of the ink amount. The solvents are from 30 to 50% of the ink amount. Then you have the binders, which are polymers, which are then binding the pigment to the printed substrate. And then you have different additives which you can add to the ink. For example, deforming agents or surface tension adjustment agents, or some waxes, for example.
Vamos a hablar ahora de los componentes de la tinta flexográfica, que tiene cuatro componentes principales. El primero de ellos serían los pigmentos de colores, aproximadamente entre un 5 y un 15%. El solvente, que es en el líquido donde vamos a disolver esos pigmentos, entre el 30 y 50%. Y luego los aglutinantes, que suelen ser polímeros, que son los que van a adherir esa tinta al sustrato. Y luego los aditivos, que pueden ser pues agentes que permitan la penetración de la tinta o otros tipos de aditivos.
So when we print something on the substrate, for example, on the paper, then after the inks are placed on the substrate, the water or the solvent is either evaporated or absorbed by the substrate. The ink are drying, and then you form the ink film where the pigments are binded by the binders to the surface of the paper.
Cuando aplicamos la tinta en el proceso flexográfico a cualquier sustrato, en este caso sería papel, o en este caso es papel, primero el agua se evaporaría, luego tendríamos una tinta seca que posteriormente haría una formación parcial de la capa impresa, y ese sería ya el final del proceso de impresión flexográfica.
There are two main process parameters which should be controlled for printing inks. Those are the pH of the ink and the viscosity of the ink.
Hay dos parámetros muy importantes que tenemos que controlar en la tinta. Uno de ellos es el pH y la otra es la viscosidad de la tinta.
And it is important to remember that actually the viscosity of the ink can be dependent on the pH. Therefore, if we are checking viscosity and pH, we should start with first checking that the viscosity is stable, and afterwards we need to start checking that pH of the ink is stable, and after checking the pH, then we check the viscosity.
Hay una relación entre el pH y la viscosidad. Primero tenemos que chequear el pH y cuando esto es estable tenemos ya que chequear la viscosidad de la tinta.
Another important parameter of the ink is also the surface tension. In order that the inks are spreading well on the surface of the paper, that they are wetting the paper, and that they are not just standing on the surface like shown here, the surface tension of the ink should be below the surface tension of the printed substrate.
Otro parámetro importante es la tensión en la superficie. Y tenemos que controlar la tensión en superficie de la tinta con la tensión de la superficie del sustrato, en este caso del papel, y la tensión de la superficie de la tinta normalmente tiene que ser inferior a la del sustrato.
Water and water-based inks, which are the most commonly used inks in the corrugated flexoprinting, they have quite high surface tension. You see here 73 millinewton per meter. And if we look at the surface tension of the paper, which is somewhere in the range of 34 to 38 millinewtons per meter, if you just look at water, water will not wet the surface of paper too well. Therefore, quite often you add some surfactants to the water-based inks in order to reduce the surface tension of the water-based inks and to improve the wetting behavior of the ink on the paper surface.
En el cuadro de la derecha vemos la tensión de superficie del agua, de los solventes de tinta y del papel. Muchas veces cuando las tintas están hechas en base agua, como vemos, la tensión en este caso sería superior a la del papel, con lo cual se tienen que introducir en ese tipo de tinta productos para que la tensión de superficie sea menor que la del papel y se produzca una buena impresión.
Good. Colleagues, I have seen that somebody rose the hand, so if you have your questions, please write in chat. You can use English or Spanish, and then we can answer it either directly or at the end of our webinar. So there is an easy way to estimate the surface tension or the surface energy of the printed substrate, and we use it ourselves sometimes. This is a set of surface markers, like shown here. Each marker has a number, like 38 or 30 or 48. And what you do, you simply draw the lines on the tested surface, and then you see for which marker you start to get the interrupted line. And if for this marker you get the interrupted line, it means that this number, which represents the surface tension of this liquid, is going above the surface energy of the substrate. So if you find two subsequent markers, one which is making the solid line and another one which is making the interrupted line, you can more or less estimate the surface tension of the printed substrate.
Una forma de comprobar la superficie la tensión de superficie es utilizar una serie de marcadores que están numerados y pasamos esos marcadores por la superficie, por el sustrato en el cual queremos conocer la tensión de superficie, y cuando la línea dibujada sea discontinua, en ese momento sabremos que la superficie de tensión de ese marcador es menor que la del sustrato en el que estamos pintando.
Moving further to Analox roll, Analox rollers is another very important part of the flexoprinting process. On the picture here, you see different type of the Analox roll patterns. For flexographic printing in corrugated, this hexagonal pattern, so-called 60 degrees hex, is the most commonly used Anilox roll pattern.
En la siguiente diapositiva lo que vamos a ver son los diferentes tipos de rodillos Anilox con los diferentes patrones de grabado. Vemos 4 de ellos y dentro de la producción de cartón, de impresión en cartón corrugado, el más común de ellos es el hexagonal con 60 grados. ¿No? 60 degrees hexagonal, ¿no?
Exactly, yes.
Okay.
If we look at the main characteristics of the Anilox roll, so besides the type of engravings, and if we look at this 60 degrees hex characteristic, is the number of these lines of cells per 1 centimeter. So basically showing you how small these cells are, how many of them you can put on 1 linear centimeter.
Dentro de este tipo de rodillo Anilox, la principal propiedad en la que tenemos que fijarnos es el número de celdas o alveolos que hay por pulgada o centímetro.
And then, obviously, as the number of cells per 1 centimeter or per 1 inch, depending which units you use, as the number of cells is getting larger, the opening of the cell is getting smaller because simply you have more and more per 1 centimeter. And if you keep the depth of the cell on the same level, basically the cell becomes very narrow and very deep. And in this case, it's very difficult to get the ink out of the cell. Therefore, if you increase the number of cells per 1 centimeter, you should also then decrease the depth of the cell. And by doing so, you decrease the volume of the cell.
Es también importante reseñar que si de alguna forma tú incrementas el número de alveolos por pulgada o centímetro, la profundidad de esos alveolos va a ser menor, con lo cual el volumen que esa célula o ese alveolo es capaz de absorber o de ser rellenado de tinta va a ser también menor.
So if you would like to increase the resolution of printing by increasing the number of lines per 1 centimeter, it also comes together with decreasing the amount of ink which potentially can be transferred from the Anilox roll to the printing cliché.
Entonces la transmisión de tinta a los rodillos Anilox se disminuirá también.
And that is exactly what you see in this table. So in the first column, you have the number of lines of the cells per 1 inch in this case. And in the second and the third column, you have what kind of amount of ink potentially the Anilox roll with such a screen count can carry. So as you see, if you go to higher number of cells per 1 inch, to higher line screen, then the amount of ink which Anilox can potentially carry is going down.
En el cuadro que tenemos en esta diapositiva, en la primera columna vemos las líneas de alveolos que tenemos por pulgada. Y en la columna de la derecha tenemos la capacidad de transmisión del Anilox de tinta. Vemos que a medida que se va incrementando el número de alveolos por pulgada, la cantidad del volumen que es capaz de transferir de tinta por alveolo es mucho menor.
And another important point to consider is what kind of paper do you print. So if, for instance, you print uncoated rough brown kraftliner, you need to have more ink than if you print, for example, a clay-coated paper. So, and the same, if you would like to print with half-tone process printing, you need to have less ink than if you want to print a solid printing. So when you decide what kind of analog cell volume you need to consider what kind of paper you're going to print and with what kind of type of printing you're going to do.
El tipo de papel que vayamos a imprimir también nos marca qué tipo de rodillo anilox o qué tipo de volumen de celdas vamos a necesitar para una correcta impresión de estos papeles. Como vemos en esta tabla, para por ejemplo, para el craft café, para el craft marrón, se va a necesitar mucha más cantidad de tinta y sin embargo, para los papeles que tengan una capa de kaolín, pues va a tener que ser menos. Luego, por tanto, el tipo de papel que elijamos para imprimir va a determinar qué tipo de anilox vamos a utilizar.
You may get a bit confused here by the units which I use. For example, here all the numbers are expressed as cubic centimeters per square meter. Here all the numbers are expressed as billions of cubic microns per square inch. Therefore, if later on you will use this presentation and you would like to convert one unit to another ones, here on the top, I also give you the simple converting formulas, how you could convert the units from the units which are used in Europe to units which are used in the Americas.
En la tabla superior vemos, es útil una tabla de conversión de lo que es porque estamos utilizando dos tipos de unidades diferentes, que sería una tabla de conversión de centímetro cúbico por metro cuadrado y de billones de micras por pulgadas cuadradas.
Another factor to consider selecting the analogs roll is the print resolution of the clichés itself. By print resolution, I mean that how many dots per centimeter or how many dots per inch the printing cliché has.
Un dato importante también dentro de lo que son los rodillos anilox es ver la cantidad de puntos de impresión que tiene por centímetro o por pulgada para una mayor resolución de la impresión o no.
There is a recommendation saying that the number of cells on the analogs roll, which deliver the ink to the cliché, has to be at least 4 to 6 times higher than the number of printing dots on the printing cliché. If you have this ratio, then you see that you will apply a controlled amount of ink on the top of the printing dot.
Digamos que lo recomendado es que el número de celdas por pulgada del rodillo anilox debe de ser por lo menos de 4 a 6 veces mayor que en el cliché.
So if this ratio is not maintained, then it may happen that, for instance, the dot can completely get submerged into the cell on the analogs, and then you will have the printing ink all over the place on the cliché.
En el gráfico superior, en la derecha, vemos una aplicación no controlada de la tinta desde el Anilox al cliché.
That was about the flexographic printing, just to give you the understanding of the main components. Now let's look at key paper properties for achieving good print results.
Serhiy, may I interrupt you? We had a question already. Where is it? And the question was from Karina. How can you measure the surface tension of ink and compare it to the surface tension of paper? I hope the translation is more or less right.
Yes, that's correct.
Okay, good.
Yeah. No, I mean there are different ways to measure the surface tension of the ink. For instance, of the liquids. For instance, if you place the liquid on the substrate with known surface energy, and you see how the liquid spreads on this substrate, so from there you can derive the information about the surface tension of ink or of the liquid.
La forma de ver las diferentes superficies, la tensión superficial, es echar el líquido de tinta sobre la superficie y ver cómo se vamos a decirlo, desparrama ese líquido en el papel.
And the same applies if you want to measure the surface energy of paper, and you have, for example, the liquids for which you know the surface energy, then simply you have to put on the paper the liquids with a known surface energy or surface tension, and then you simply observe how these liquids are spreading on the surface of paper.
Y lo mismo haríamos si conociésemos la tensión superficial de un líquido y quisiéramos comprobar la de la superficie del papel, veríamos el comportamiento de ese líquido en la superficie del papel.
I hope that answers the question. If we then move further to the properties of paper, then I would split the properties of paper important for printing in the following categories. This is formation, the surface strength of paper, the roughness of paper, the optical properties of paper, the paper porosity, and the paper surface and wet end sizing.
Las propiedades del papel que nos van a determinar, digamos, que rigen dentro de la impresión sería la resistencia de la superficie, la rugosidad, las propiedades ópticas, la porosidad, la superficie y el encolado del papel y la formación del papel.
So let's start with looking at the surface property, at the paper appearance. I think you all can relate to this picture when you put next to each other a few white papers. These white papers, they can look different.
En la fotografía que vemos a la izquierda es típica foto donde vemos tres papeles blancos donde superponemos unos a otros y vemos a la vista, pues para el ojo, cuál papel es más blanco.
And obviously, if you put the same amount of ink on these three different papers with different properties, optical properties, also the print may look also different.
Y si le aplicamos tintas con diferentes tipos de tinta, obviamente la impresión va a ser diferente en los tres tipos de papel.
To characterize the optical appearance of paper, we use two main methods, which we call brightness and also whiteness. In the brightness method, we shine some light on the paper surface, and then we see how much of this light is actually being reflected by the paper surface. The percentage of light which is being reflected is roughly telling you the brightness of paper. So the higher the value, the better it is for the paper.
Para ver la blancura del papel utilizamos dos mediciones, que sería la medición del brillo y la blancura. En el caso del brillo nos está midiendo la absorción o reflejo de la luz azul, y digamos que cuanto más refleje, pues más blanco será el papel.
The brightness gives you the overall information about how well the paper reflects light, but it doesn't give you really the information about the color shade of a substrate. Therefore, we complement the measurements of brightness with the measurements of so-called L, A, and B values of paper. And as you see here, L, A, B values tell you whether the paper has a yellowish or bluish tint, greenish or reddish, whether it is lighter or darker.
La blancura del papel nos la da teniendo en cuenta la tonalidad del papel, que puede ser amarilla, azul o una combinación de ellas. Puede ser más amarilla, puede ser más de tipo azul.
And whiteness, which is given normally in specification as one number, whiteness is calculated from these paper color coordinates.
La blancura, el whiteness, es calculado por estas coordenadas el valor del whiteness nos viene calculado por estas coordenadas de colores, de tonos, perdón, de tonalidad del papel: amarillo, azul, verde, rojo.
Okay, may I quickly interrupt? We have a question concerning this table of the size of the analog scroll. And if you look in the chat, question was, there is, so about the CB pen, what is the rugosity of the paper? So the roughness of the paper. Do you have the same table for all the type of cells of the analog scroll? And Salvador put as well. So, but which parameters you to use in this table? Because the roughness and the porosity of the papers you use in Europe are different to the ones they use in Mexico.
Yeah. Of course, brown kraftliners they can be different. Some of them they're calendared, some of them they're not calendared. They will have different roughness, and therefore, as they have different roughness, they will also require different amount of ink. So obviously, in this table, you have the ranges, but these are the indications. So of course, some of the brown papers which have very smooth surface, they may need even less ink, and some other ones which are not calendared, they may use even more ink. So obviously, this table is just to give you an understanding what is the principle. Let's say the numbers has to be, of course, tested with the given substrates which you use at your plant.
La tabla que mostramos en esta diapositiva lo que nos da es una indicación realmente. Obviamente, cafés, craft marrones, los hay de muchos tipos, que están calandrados, que tienen una mayor o una menor rugosidad, y obviamente para craft liners que hayan pasado por una calandra, que tengan una superficie menos rugosa, pues la cantidad de tinta a aplicar será menor que en un craftliner café donde no se le haya aplicado una calandra y donde tenga una rugosidad mayor y donde por lo tanto haya que aplicar más cantidad de tinta. Pero repito, en esta tabla lo que damos es una indicación para que se vea que diferentes tipos de papel tienen diferentes tipos de uso o diferentes tipos de cilindro anilox. En cada uno de ellos también habrá que mirar lo que acaba de decir Serhiy, si están calandrados, si no están calandrados, si la rugosidad es mayor o la rugosidad es menor.
And I will speak later about how you could possibly evaluate in laboratory what kind of Analox roll could be required for your substrate, because at the end of the day, you need to deliver the sufficient amount of ink to cover the paper surface with the ink, and at the same time to use the highest line count, because having highest line count, you can achieve the better quality printing. This is the principle. So use the highest line count of Analox roll, which is giving you the sufficient ink volume to cover the surface of the paper which you print.
Y luego, como teoría general, el uso de mayor cantidad de líneas de alveolos nos va a dar una calidad de impresión mejor. Eso como norma general.
Good. I hope I managed to bring some clarity to this point, but if you don't mind, we continue, and then we can always come back to these questions at the end of the presentation, or even we can have a personalized discussion after our webinar that we have. So I move back where we have been. So we spoke about brightness and whiteness. Another important point is to understand how paper interacts with water. And one of the ways to do so is use the contact angle measurement, where you put the drop of water on the surface of the paper, and you measure the contact angle here. So how big is the contact angle?
Un dato importante también a la hora de ver el potencial comportamiento del sustrato, del papel que vamos a utilizar, es hacer una prueba con una gota de agua y ver el ángulo que forma la gota, el ángulo de contacto entre la gota y la superficie.
And we have tested many different containerboard papers, virgin papers or recycled papers, and what we see that most of the papers, they have a contact angle in the range from about 85 to about 110 degrees. This seems to be the proper range for the contact angle of water on the paper surface.
Dentro de Mondi se han hecho testeos con una gran cantidad de papeles, tanto papeles vírgenes como papeles reciclados, y el rango donde, digamos, el ángulo tendría o la superficie sería correcta es para aquellos en los que la gota tiene un ángulo de contacto entre 85 y 110 grados.
Then we also have the other ways, let's say more standard ways to look at the interaction of paper and water. I think all of us, we know the Cobb method, which is widely being used. Then we have a drop test method, where you put a drop of water on the paper surface and you measure how much time it takes for the drop of water to absorb. And this type of the test is normally done only for unsized papers. Or there is another type of test, a so-called penetration dynamic adsorption test, where you put a piece of paper in the water and then you let the ultrasound to be transmitted through the paper, and with passing the ultrasound through the paper, you check how quickly paper absorbs water into the pores.
Tenemos otra serie de test donde nos muestran la interacción que tiene el agua con el papel. El primero de ellos, el conocido por todos, el test COP. Luego estaría el test de caída de gota, que se utiliza sobre todo en papeles que no estén encolados y que nos mide el tiempo que el papel absorbe la gota. Y el último sería el PDA test, donde nos dan la penetración dinámica de absorción de la gota sobre el papel. Perdón, del papel sobre la gota.
I mentioned before that the surface strength of paper is important, showing how closely the fibers are connected. Because if the fibers are not well connected, you can easily pick them in printing, and then you have various kind of printing issues. And the bonding between the fibers we are testing with the Denison wax method, where we put different waxes with different affinity strength toward the paper, and then we pull them off, and we see what kind of wax number start to pull some fibers out of the paper surface. And the higher the number, the better it is, because higher wax number means that the bonding between the fibers is stronger.
La prueba de las ceras Denison lo que nos está, que mide también, o es otro de los que miden la resistencia o la fuerza de los papeles, nos está midiendo la resistencia de los papeles bicapas a separarse uno de ellos. Las ceras, cuanto mayor es el número de la cera que hemos utilizado, mayor es la resistencia, cuando el número de la cera que hemos utilizado en la que se quedan pegadas fibras, nos indica que mayor es la resistencia de las dos capas a despegarse.
And now we come to paper roughness, which by many considered as very important, or maybe the most important printing property of paper. And there are different ways to measure paper roughness. The most common one used for uncoated papers is the Benson method. And for coated grades, quite often you may hear the name Parker Print Surf Test.
Dentro de la medición, que es muy importante dentro de las características del papel para ver su potencial tipo de impresión, sería la rugosidad. Y el test más conocido es el Benson, que se suele utilizar para los papeles que están estucados. Sí.
Yeah, and how the test is working, that you put a piece of paper on the glass plate, then you put the measurement head on the top of it, you apply certain pressure, and then you let the air to flow from under the measurement head outside. And then you measure how much air is actually flowing, and the more air is flowing, the more rough a paper surface is. And both the Benson and the PPS method, they work on the similar principle.
El proceso, cómo trabaja el test Benson, es poner la muestra de papel a analizar encima del plato de cristal, y vamos a aplicar un flujo de aire, y lo que vamos a medir es cuánto flujo de aire se elimina por minuto. Cuanto más bajo sea ese valor, representa una superficie más suave, y al contrario, Cuanto más alto significa que tiene una mayor rugosidad. Y el test Parker, pues más o menos utiliza el mismo tipo de procedimiento de trabajo.
And the biggest difference is actually the width of this measurement wall of the head. So here for Benson, it is the width is 0.15 millimeters, and for PPAs it is only 0.051 millimeters. So it is much more narrow, and that's why Benson is more sensitive for measuring more rough uncoated papers, and the Parker PPS method is more sensitive for measuring smooth coated papers.
La diferencia principal entre ellos es el ancho del anillo que se utiliza de metal para obtener la presión del aire, donde en el Benson es de 0,15 milímetros y en el Parker Print es de 0,051 milímetros. Por lo tanto, en la Benson nos da una mayor sensibilidad a los papeles con una mayor rugosidad. Y en los papeles Parker nos da una mayor sensibilidad en aquellos papeles que tienen mucha menos rugosidad.
The next few slides I would like to skip because they are basically repeating to what we have discussed in the more sophisticated way. So therefore, if you don't mind, I will go over them. And I will come to paper formation, which is also important for having low print model. So I think you all are familiar with the formation. Formation shows you how well the fibers are distributed across the paper sheet. Here you have an example of paper with a good formation, and here you have an example of paper with poor formation. And formation can be simply measured by looking at paper through the light, and then you see how even the surface of paper is.
Otra característica importante es la formación del papel y el análisis de esa apariencia. Simplemente tomando una pieza del papel a analizar, lo pasamos a través de la luz y vemos si ese papel tiene zonas de poca concentración de pasta, lo que nos daría, como en la fotografía de la derecha, una mala formación de papel, o realmente existe una concentración de fibras por todos uniforme, lo cual nos daría una buena formación como la que se observa en la fotografía de la izquierda.
There are also other ways to look at the formation of paper. For example, there is an instrument which is called Ambertech unit, where you have a scanner here. You put a piece of paper on the top. You shine the light, or you send the radiation through the paper sample, and then by this detector you can recreate the variation in the thickness of the paper. So you can clearly see how big are the variation in terms of the fiber concentration in the paper.
Tenemos en esta diapositiva dos formas de analizar la formación del papel, diferentes a la que hemos dicho antes, de sencillamente poner la pieza del papel a la luz. Uno de ellos, el Ambertech, que sería pues coger un trozo del papel y pasarlo a través de un escáner, y nos daría, como en la gráfica que se muestra, una topografía de lo que es ese papel y de la concentración de fibras en toda su superficie.
This method is good when you evaluate the material made out of one layer, for example, but if you have two-layer materials, in particular, if you have white top kraft liner consisting of two layers of brown and white layer, in addition to just looking through the light which goes through paper, you also want to look how well the white layer is covering the brown layer. And that's why we also use a so-called Cheops instrument, where we shine the light on the paper on the white side, and we see how evenly this light is reflected from the white side of paper. If you have poor formation of paper, the light will be reflected not evenly, and we will be able to see it with this instrument.
El test por el instrumento Ambertech, bueno, normalmente se utiliza solo para papeles que tienen una sola capa, que tienen una sola hoja, pero para papeles como puede ser el white top, que está formado por dos capas, la blanca y la marrón, o incluso en muchos craft liner que están formados por dos capas, se recomienda la utilización del instrumento Cheops, donde se hace a través de una cámara y nos mide cómo refleja el papel y nos proporciona un índice de formación. Y además de dirección, lo cual nos permite comprobar para papeles con dos hojas si este está formado correctamente.
Now, that was all, colleagues, about the paper properties important for printing. Now I would like to use a few minutes of your time to speak about the white liners for flexographic printing.
Vamos a hablar ahora de los papeles blancos en la impresión flexográfica.
So here you see all possible type of the containerboard papers, liners and fluting, virgin papers and recycled papers. I would like to only focus on the white liners. And for white liners, we have fully virgin white top craft liners containing one white layer and one brown layer of virgin fibers. We have fully bleached papers, which are made out of one or two layers of white virgin fibers. And we have white top test liners, which contain one white layer made out of recycled fibers and one brown layer made out of recycled fibers. There are, of course, different qualities of white top test liners, A, B, and C quality, but the composition is the same for all of them.
En esta diapositiva vemos todas las posibilidades de diferentes tipos de papel, pero para esta presentación nos vamos a centrar en los papeles blancos, en los que tenemos los diferentes tipos, que empezaríamos por craft blancos, que son 100% fibra virgen, con una capa blanca y una capa marrón. Los fully bleached, que son formados por una o dos hojas de fibra virgen blanca. Luego tendríamos los craft top liner, que tienen una hoja blanca de fibra virgen y una hoja marrón de papel reciclado, y luego toda la categoría de test liner blancos en sus diferentes tipos A, B y C.
White top craft liners, fully bleached liners, white top test liners have been already for quite a long time on the market. However, what we are going to present here is the paper which is combining the fresh virgin fibers on the top with brown recycled fibers on the bottom, so-called craft top liner white.
A continuación vamos a presentar la combinación de una hoja de fibra virgen blanca y una hoja de fibra marrón reciclada llamada craft top liner.
And this is exactly the paper grade which we are going to produce at our paper mill in Slovakia, where basically just a few weeks ago we started a new paper machine which will produce about 300,000 tons of paper per year.
En esta diapositiva vemos dónde está localizada precisamente la fábrica de Mondi en la República de Eslovaquia, en Luzan, donde hace unos días hemos comenzado la producción de estos tipos de papel con una producción máxima aproximada de 300.000 toneladas.
So this paper will be constructed of 2 layers, as mentioned before, fully recycled base layer and fully virgin the top layer of paper. And because of that, we expect that the paper will have a printability and appearance on the same level as regular white top kraftliners. And because we will use a high quality recycled fibers, plus we will use a good quality fresh fibers, plus we will use a surface application of starch, the strength properties of this paper, especially speaking about the SCT values, will also be on the same level as white top kraftliners.
Como hemos indicado antes, este tipo de papel tiene una capa reciclada marrón, sirve como base, y una capa blanca 100% fibra virgen con la aplicación con añadido de almidón, que nos va a dar una capacidad de impresión equivalente a la que pueda tener un white top, un kraftliner blanco, producidos por Mondi, y unos valores SCT comparables a los del kraftliner blanco.
If we speak about the grammage range for this new product, we plan to start with producing paper starting from 100 GSM up to 175 GSM. And in the future, if there will be a demand, we can also go down in grammage down to 80 to 90 GSM range.
Con respecto a los tipos de gramajes, a producir, comenzaremos con la producción de un gran abanico de gramajes, desde los 100 gramos hasta los 175 gramos, y en un futuro incluso tendremos la posibilidad, o comenzaremos la producción de este kraft top liner blanco en 80 y 90 gramos.
The paper will also be available with FSC and with PEFC certification, confirming that the raw materials come from sustainable sources.
Además, los tenemos con la certificación FSC o PFC.
If we compare this paper with white top kraftliner or different qualities of white top testliners, in this case, the paper is compared in terms of SCT index and the burst index. The values here for kraft top liner are taken from our guaranteed technical data sheet, so it is not. So the SCT and the burst index, they are not the average values, they are the minimum values which we are going to have for this paper. And they are compared with the minimum values of white top kraftliner or white top testliners as defined by the CEPI, European Confederation of the Paper Industry. And you see that this paper, speaking about the SCT values, will have better values than even white top kraftliners. Speaking about the burst values will be a little bit lower than for white top kraftliners, but still higher than for all recycled liners on the market.
En esta diapositiva vemos los valores mínimos de los diferentes papeles que estamos comparando. Por un lado están los diferentes tipos de testliner blancos a la izquierda de la gráfica, y a la derecha, en azul, la barra azul, los valores de kraftliner blanco, y en naranja los valores del kraft top liner smart white producido por Mondi, en donde vemos que los valores SCT para el mismo tipo de gramaje son incluso mejores que los del kraftliner blanco, y los valores de estallido, de burst, están un poco más bajos que los del kraftliner blanco, pero bastante superiores a los 3 tipos diferentes de testliner blancos, calidad A, B y C.
And the similar picture we see if we look at the comparison in terms of brightness and in terms of surface roughness. the craft top liner that we will produce, shown here by the orange column, will have the minimum brightness on the same level or higher than white top craft liners and the white top test liners. And at the same time, having highest brightness, it will also have a lowest surface roughness.
En esta gráfica vemos la comparativa de los diferentes valores mínimos de blancura y de rugosidad, donde vemos que la blancura del Smart White, el mínimo garantizado, es mejor que un test liner blanco de calidad A o del mínimo garantizado por los craft liner blancos, y la rugosidad es mejor que cualquiera del resto de los papeles. Menor valor significa una superficie más lisa.
We spoke before about a Cheops test, if you remember. So the Cheops is telling you how homogeneous the surface of paper look like. And again, we tested a number of market samples for different types of test liners and craft liners. And again, what we found out that actually the paper which we are producing will have the best, the lowest level of mottle of the papers which we have tested.
Como vimos antes, con el test Cheops comprobamos la formación de la superficie, la homogeneidad de la superficie del papel. En este caso también vemos que en el caso de este papel, Craft Top Liner blanco, Smart White, los valores que nos da el test de Cheops son mejores que el resto de papeles de calidad A, B, C, o incluso del craft liner blanco, ya que los valores más bajos que tenemos en la columna de la izquierda nos dan menos problemas de impresión, mejor formación de hoja.
Exactly. And also, if we speak about the formation of paper, about the Ambertech numbers, again, you see that the lower the number, so here is the X is a little bit inversed, so the lower numbers are shown up, and you see again that the Provatnich Smart White product or this Craft of White product will have also very good formation. So appearance and formation will be a strong properties of this paper.
Y en esta gráfica vemos que con el test de Ambertech, exactamente igual que ocurría con el test Cheops, los valores el Craft Top Blanco Smart White tiene una mejor formación de papel, es decir, valores más bajos, mejor formación en comparación con el Craft Liner blanco y el resto de test blancos.
So that was all about the new product which we are going to produce. So we look forward to also hear your feedback once you try it, yeah, we are looking forward to it. Now let us speak a little bit about the common print defects which we receive from our customers, and let's have a discussion around that.
Pasamos ahora a ver los defectos más comunes en los procesos de impresión.
I mentioned before that we also can test the quality of flexo printing in laboratory. Of course, it is not the same as the real life printing press, but nevertheless, using such, for instance, RK flexoproofer or using the FlexiProof instrument, we are able to use different Anilux rolls with different cell volume. We can use different amount of ink here. We can use different imprinting pressures. And actually, with this simple instrument, we can reproduce quite well some of the printing defects which are observed also at the bigger real-life machines.
En esta diapositiva vemos dos instrumentos, el RK Flexo y el FlexiProof, que lo que nos hacen es que nos permiten reproducir situaciones reales de impresión, nos permiten cambiar rodillos anilox y nos permiten imprimir con diferentes velocidades y con diferentes volúmenes de tinta, y nos permite recrear situaciones en nuestro sistema flexo de impresión y con bastante realidad.
Here I just give you the example of how the printed paper sample look like with these small machines. You have here two lines. One line above was printed with an ink volume of 8 centimeters cubic per meter square. The line below was printed with a smaller ink volume, 7 centimeters cubic per meter square. And also they were printed with different Anulox rolls, above with 100 lines per centimeter and below with 120 lines per centimeter. So as we have discussed before, you can test with this instrument different type of Anulox rolls as well, with different line counts, with different cell volume, and to understand whether the amount of ink which you will apply, whether it will be sufficient to achieve a proper coverage of your printed surface.
En esta diapositiva vemos claramente dos ejemplos de dos tiras impresas en los instrumentos que hemos visto anteriormente, con diferentes líneas de impresión por centímetro, volumen de tinta por alvéolo, y vemos claramente la diferencia entre esas dos impresiones.
And now let's have a look at some of the printing defects which may happen. On this picture, you can see some lines on the solid printed areas here and here. These lines, they in this particular case come from the uneven starch application on the surface of the paper. So because the surface starch was not evenly applied, it was applied with this kind of streaks. When you put an ink over it, sometimes you can also see this kind of streaks on the printed surface.
En esta primera diapositiva vemos en la fotografía de la derecha unas líneas de impresión en la superficie provocadas por la desigual aplicación de almidón en la superficie del papel a imprimir.
The next type of the defect appears as so-called shadow marking. So if you print a solid area, you can see this very regular structure on the printed surface. Quite often that happens because of these defects originate from the press section of the paper machine. When you press the paper in the press section, some of the press rolls, they have a surface with a drilled holes in it to improve the removal of water. And if you press too much and the press felts are already old and worn out, sometimes you can get this kind of uneven paper formation because of this pressing. And then obviously in printing, you can get this effect.
En este caso vemos un ejemplo en el que la producción de este cartón corrugado nos muestra de diferentes tonos, provocado por el proceso de secado durante la producción del papel en la sección de prensa, en la que aplicación de diferente presión en ambas partes puede provocar una diferencia de cantidad de humedad en cada una de las secciones, lo que provoca al final diferente absorción de tinta en la misma superficie.
Another defect which I think you all recognize is so-called poor ink transfer in the valleys between the flute tips, and this kind of defects can be caused either by too high roughness of paper or by too small amount of ink transfer, or simply by too strong washboarding effect of the corrugated board. What is the root cause exactly? It has to be analyzed in every individual case, but it is, as I mentioned, one of these three options.
En este caso, en el que vemos una pobre cubierta de tinta en el cartón impreso, que puede estar provocado por tres diferentes causas. Una de ellas es que el papel, por el secado del papel, porque haya una pobre transferencia de tinta, o que haya un problema de marcado de canal, washboard.
The opposite effect of washboarding is when you apply too high pressure in the printing. You don't have the issues with the ink transfer in the valleys, but you have this, let's say, distinct and strong lines on the flute tips. So obviously, because you have a higher imprinting pressure on the flute tips, you also get darker color there.
También podemos tener bandas en la superficie del cartón provocado por las variaciones en la presión durante la impresión que marcan las canales del cartón corrugado.
Then sometimes we also receive the remarks about insufficient ink coverage on the paper surface, as is shown here on these pictures. Again, similarly to washboarding, it can happen either because of too high roughness of paper, or because of too high viscosity of the ink, because ink is not spreading well enough on the surface of paper, or simply because the amount of applied ink is not sufficient.
En este caso también tenemos un pobre recubrimiento de tinta provocado por una ineficiente aplicación de transferencia de tinta o insuficiente, o también debido a una alta viscosidad de la tinta que provoca una menor transferencia de tinta al cartón.
Another example is a small unprinted dots on the full block printed areas, which under microscope look like a small printed dot in the middle, and then you have an unprinted circle around. And this is a clear indication that something got stuck to the printing cliché, therefore preventing the contact of cliché around this stuck area. So this is a clear indication of some contaminations, either in the ink or in the printing unit.
En este caso vemos los problemas de impresión que pueden estar provocados por las partículas adheridas al cliché, o incluso por contaminación dentro de la fórmula de la tinta.
Here is another example of such unprinted areas. In this case, you don't have any printed area in the middle, but it was also clearly the effect of some contaminations, because as you see here, the unprinted areas were always in the same position. So it means that with every rotation of the printing cliché, you always had unprinted area in the same position. So obviously also the indication of some contaminations.
En este caso vemos dos planchas o dos láminas impresas en la que claramente vemos que los problemas de impresión se producen exactamente en el mismo sitio, lo que nos está indicando que hay una contaminación en el cliché o una contaminación en la placa de transferencia.
Then sometimes we also, not often, but it can happen that you have some contaminations already in the paper. some kind of pitch contamination, then obviously they can also appear on the printed areas as shown on the pictures here.
En este caso también puede haber contaminaciones, es no tan común, pero en este caso contaminaciones de alquitrán, por ejemplo, que nos provocan esos puntos en la impresión del cartón.
Then one more type of the issue can be variation in the print density. So some of the printed corrugated boards have a higher print density, some have lower. And here you really need to look whether the ink application amount was the same in both cases, or if the substrate had the same adsorption properties. So you need to look at the properties of paper, but you also need to ensure that you have the same application of ink and the same viscosity of the ink.
En este ejemplo vemos una variación en la densidad de la impresión que puede deberse a dos causas. Una de ellas puede ser a que la cantidad de aplicación de tinta sea menor en el segundo caso, o incluso que el papel tenga una capacidad de absorción menor, con lo cual en este tipo de problemas siempre tendremos que chequear ambas cosas, el papel que estamos utilizando y la aplicación de tinta que le estamos dando.
Then, for instance, we also sometimes receive such type of printing topics where you see very dirty print on the surface. And in this case, we actually analyzed the corrugated board, and we found out that actually it has very low COP. So clearly there was some wax application somewhere in the process, likely because it was fish boxes, so the boxes were wax coated for the inner liner, and then somewhere in the stock you had a wax migration from the inner liner to the outside liner, and because of this migration of wax, you had such issues with adsorption of the ink. So wax adsorption, undesired wax migration can also cause some printing problems.
En este caso vemos un problema de impresión. Una vez testeado el cartón, el papel liner impreso, comprobamos que tenía un COP muy bajo, posiblemente por una aplicación de ceras, en la que ha habido una migración de la cera desde el liner interior a la superficie, lo que ha provocado esa variación de COP y, por lo tanto, esa diferente tipo de impresión en el papel.
With that, I'm coming to the end of my presentation. Obviously, we did not cover all possible print defects, but I think that at least the ones which are, let's say, about which we hear most frequently from our customers, I think that this was those. So what I would like you to remember out of my presentation, so first of all, the flexography is a main printing process in the corrugated industry. Selecting the right tire combinations of the printing plates and annulus rolls for your substrate is very important to achieve good print results. Then paper with a rougher surface, they absorb more inks, and therefore obviously they also require the annulus roll with higher ink volume. The brightness, roughness, sizing, the surface strength and formation of paper are key for achieving good print results. I also hope that you will remember about the new Kraftop liner grade, which is produced by Mondi nowadays in Slovakia. And also, last but not least, I would like to point out that to achieve a reproducible print results, you have to use paper with excellent surface properties. You have to make out of this paper the corrugated board without washboarding. And obviously, you have to use a stable ink quality and application amounts. And also, you have to maintain the cleanness in your printing equipment, and then the print results should be satisfactory and reproducible.
Bien, finalmente, como resumen de la presentación de hoy, me gustaría decir que la impresión flexográfica primero es la predominante en el mercado del cartón corrugado, que la selección de los clichés y los rodillos anilados correctos es crucial para obtener buenos resultados, que los papeles con una superficie más rugosa requieren más tinta, que el brillo, la rugosidad, el encolado, la resistencia y la formación son las propiedades claves para una buena impresión. Recordaros el nuevo papel híbrido producido por Mondi en Luzan con excelentes propiedades en la superficie comparados con craftliner blancos y tes blancos. Y por último, las recomendaciones para una buena impresión, que sería un papel con excelentes propiedades en la superficie, un cartón sin el washboarding, mantener limpios las superficies de impresión y los clichés, una viscosidad de tinta estable y una aplicación de tinta suficiente para poder conseguir buenos resultados de impresión.
Thank you very much, Luis, for your help today. Thank you very much. Yeah, thank you very much, colleagues, for staying with us so long today. We went slightly over time. We planned to do it in 1 hour, but obviously with a simultaneous translation, with a translation, it's a little bit difficult. Therefore, we thank you for your patience. We hope that you found the material shown today interesting for you. I think that as we stayed already quite long, we will take your questions which you have submitted. And as we have your email addresses, we come back to you individually later on with the answers to our questions. And if you will have questions after today's presentation, you can always reach out to us, and we will be happy to answer your questions also after the webinar as well.
Muchas gracias. El seminario de hoy ha durado más de lo que habíamos pensado, pero la traducción, que no es simultánea, pues lo complica un poco, y esperamos que haya sido interesante, y cualquier pregunta puede ser contestada más adelante por Serhiy directamente. Via email, ¿no, Serhiy?
Yes, via email, or even now the questions which we have received in the chat. We know the emails of the people who submitted the questions, and we will come back on these questions with the answers directly then to the people. And if there will be the new question, they can always ask by email, and I will be happy to answer.
Se pueden seguir haciendo preguntas a través del chat, o más adelante se pueden utilizar a través de email y serán contestadas por Serhiy sin ningún problema.
Good. Then thank you very much, colleagues, and all the best to you. Take care, and hope to see you for our next webinar in a couple of months.
Muchas gracias a todos, y os esperamos ver en el próximo webinar organizado por Mondi. Buenos días o buenas tardes, ya no lo sé, en Latinoamérica.
Okay. You can keep still. Maybe we keep a few minutes that you can type in the questions if you have. And in the meantime, I just put in my email address. I think just in case you don't have it, so you can answer the questions later on. You can send in the questions to me. I just see how I can send it to all attendees. Yeah, you can send the email, the questions to me directly on my email address, which I have sent to you just now. Or I think that there is also a general email address, corrugatedpaperexpert.com. If you send it there, I also receive them, and we will answer them to you. I see a question also while we're waiting a few minutes. Norma asked if we will consider to produce 200 GSM. I would say nothing is impossible, but this is not a plan for now because at this grammage, this is not, let's say, the optimum grammage for the paper machine. So let's say we would rather go into the lower substance than into the higher substances.
No consideramos la producción del 200 gramos. Todo lo contrario, la idea es crecer en gramajes más bajos, como hemos mencionado antes, con el 80 y 90 gramos.
Okay, then so I think we can close the session today. Once again,
yeah.
Thank you very much. Thank you very much, Sasha, Luis, for staying so late with us. And I think it's a pleasure as always. Okay.
Okay, guys.
Have a good day.
Take care. Bye-bye.